Counting is of the utmost importance to our lives as humans. As the revered author Dr. Seuss once said, one fish, two fish, red fish, blue fish. Today, I'm going to explain some of the basic principles of counting. One of the key rules of counting is the product rule. This rule states that given a procedure which can be broken down into a sequence of two tasks, where there are x ways to perform the first task and y ways to perform the second, then the product xy is the total number of ways to perform this procedure. To understand this definition more clearly, think of a scenario where you are trying to figure out some information in class. Let's say, for example, you are trying to figure out what is going to be on the test, what is not going to be on the test, and what the probability of you passing the test is. In order to find this information out, you decide to ask some authority figure in the class. The people you can choose from are Dr. Boucher, the head TA, or any of the other 5 TAs in class. There are a total of 7 people that you can ask information from, and 3 different choices of information that you can ask for. This leads to a total of 7 times 3 equals 21 ways that you can complete this task by the product rule. Another commonly used rule when counting possible ways to complete a task is the sum rule. The sum rule states that if there's a task where there are either x or y ways to complete it, with x and y being different, then there are a total of x plus y ways to complete the task. Continuing the example of our classroom, consider a situation where we are choosing a single representative for our classroom. Let's say that there are a total of 208 students in the class, 6 TAs, and 1 professor. We consider x to be 208, y to be 6, and z to be 1, giving us a total of 215 ways to select the representative.
Quick maths!
Now imagine you took the first test in class and didn't quite get the grade you wanted. If you want to remedy this situation, you could utilize the subtraction rule. The subtraction rule states that if a task can be completed in either x or y ways, then the total number of ways to complete this task is x plus y minus the ways that are common to both x and y. So for instance, if your plan was to log into Dr. Boucher's UF account to change your grade on the first test, you would need to utilize all 3 rules, the product rule, the sum rule, and the subtraction rule. Let's say that, for some reason, her account password is 8 characters long, and you figured out that it either starts with an F or ends with a Q, but not both. If her password only consists of lowercase letters, then we can use the subtraction rule to calculate the total number of possibilities for her password. We must first account for all the ways her password could be constructed. If she has an F at the start of her password, then that leaves 7 characters remaining, each of which can be any lowercase letter in the alphabet. This ends up being a total of 26 to the 7th possible passwords. Having a Q at the end of her password provides the same result with a total of 26 to the 7th possible passwords. However, what we did not account for is that some of the passwords starting with F will also have a Q as the last character, and vice versa for those ending with Q. Thus, we must use the subtraction rule and remove all the possible passwords that contain both an F at the beginning and a Q at the end, a total of 26 to the 6th passwords. Our total number of possible passwords to log onto her account is 26 to the 7th plus 26 to the 7th minus 26 to the 6th, which is equal to a lot of passwords.
I had 4 biscuits and I ate 1. Then I only had 3.
Now we are moving on to one of the more difficult topics to conceptualize, the division rule. The official definition of the division rule is as follows. There are n over d ways to do a task if it can be done using a procedure that can be carried out in n ways, and for every way w, exactly d of the n ways correspond to the way w. In order to simplify this definition, think of the situation where you are trying to sit people in a circle around a table. There are 4 chairs at the table, which would mean that you would think there should be a total of 4 factorial possible ways to arrange the people. However, for this example, we are going to consider a seating to be the same if a person has the same neighbors. Therefore, no matter where we sit the first person, they are simply just going to be shifting all of their seatings over by a position place, but keeping their neighbors the same. Thus, there is actually a total of 4 factorial over 4 possible seatings by the division rule. Some vital tools that can be utilized when working with counting are permutations and combinations. A permutation is an ordered arrangement of a set of distinct objects. Note the distinction on the word ordered, where something such as the ordered pair 1-2 would be different from 2-1 in a permutation. A situation in which a permutation will be used is something like a line of people where order matters. Consider the situation where you have Dr. Boucher and 6 TAs who have been charged with conspiracy to torture UF students. There are only 5 spots available in the police lineup, and we are considering a lineup to be different if the order of the participants is different. To figure out how many possible lineups there are, we would have to use the permutation formula, p equals n factorial over n minus r factorial. In this case, n would be 7 as there are 7 total people, and R would be 5, as we are attempting to choose 5 people from this set of 7 distinct people. This gives a total of 2,520 ways to select this lineup, given that order matters. However, what would we do in the case where we want to determine the number of different lineups, but we do not consider the order of the lineups? In this situation, we would utilize a combination. Combination is an unordered selection of R elements from the set and is given by the formula C equals n factorial over R factorial times n minus R factorial. N in R would still be the same in this case, and the formula would tell us that there are only 21 possible ways to select 5 people from a total of 7 people.
We would like you to think of the possibilities.
The last topic we will be covering today is probably the simplest out of all the topics in this chapter, the pigeonhole principle. The pigeonhole principle states the following. If there are k plus 1 objects placed into k boxes, where k is a positive integer, then at least one box contains 2 or more objects. Let's say, for instance, that after the police lineups, Dr. Boucher and 4 of the TAs were sentenced to 5 years in prison for their crimes. However, there are only 4 cells available in this prison. Attempting to place these 5 people into 4 cells would require that one of the cells contain 2 or more people, thus fulfilling the pigeonhole principle.